Okay, hello everyone, welcome back to my channel, Good Learning channel. So today we're going to discuss about the curve or exactly for the pump curve as same topic as my previous video. So for the pump curve, I want to dive first. What is the meaning of the pump curve? Okay, for today, I just want to share what the pump curve will be. And then okay, so basically we have two parameters here. Okay, the y-axis is for the head of the pump, and the x-axis is the flow capacity of the pump. Okay, so all of the pump, or especially for the centrifugal pump, will have the pump curve like this. It will be highest in the first and will decrease when the capacity increases. Okay, this one. And for the system curve will be increase, the the head will increase when the capacity will increase too, like this. And the pump operation will be in here. So this is the preferable zone of your pump will operate. Pump operation. Okay, so in this video I want to focus to how we can determine the flow of the capacity of this pump. This is the key rate or design, and the head rate of the pump, this one. Okay, so let's take a look for the first. So I can draw the example for you is we have to some tank in here. Okay, and then it will pump to another location. Just figure out that this pump to two brains. I will make it two brains. Just want to, okay. There is some cooler, and there's cooler 2 in the top. We'll combine, and the second bridge will go to the tank. Let's figure out this schematic drawing. So in this case, pump will transfer the fluid from the tank 1 to the tank 2, and cooler 1. Let's put some detect number here for the cooling water 1 and the cooling water 2. Okay, so let's detail it for the each schematic for this one. Okay, let's take a look for this one. Okay, so you have to define first how demand of the cooling water for both of the cooler, and you can sum to the capacity of the tank in here, tank 2. So you need to quantify first for the Q1, for the cooling water 1 and cooling water 2, and the Q2 for the total demand that you will turn, that the fluid will be transferred to tank number 2. So for the key pump or key rated in here, so I can write that the key rated is equal to Q1 plus Q2. Okay, so this is the basic of the equation. Okay, and then I will explain so what we expect for the value for the Q1 and the Q2. Okay, let's go first for the Q1. Q1, we know that some heat exchanger that will transfer heat to, so we need to quantify first how much the heat will be transferred during the operation of the cooling water 1 and the cooling water 2. You can use just the energy balance that the head is mcp delta t, and you can quantify if the, let's say, the head 1, and you can transfer to the just okay, q cw1 cp delta t, and then you can get the qcw1. Okay, cw1 is the total heat that will be transferred and divide to cp delta t. You can use the same equation to the q cw2 a2 cp dt. So it's just a disclaimer that cp dt, if the cooling water is just the sensible heat, not vaporized, because I just assume that the cooling water is just in liquid phase, not in vapor phase. So the cooling water will have the increasing of the temperature, but for the phase is fixed in liquid. So there is no evaporation or latent heat in here. So it's just a simple equation. So you can calculate for the Q1 is equals to key CW1 plus key CW2. Okay, for the Q1 you can put in here. Okay, let's take a look for the key 2. Okay, for the key 2, if the fluid will come here, key 2, and then there's a tank that you have to fill it out. And okay, so for the instance, you need the holding time in here. You need the holding time. So the holding time is basically define how much your project specification time that the two tank number 2 will handle some fluid. Let's say that the holding time is equal to 2 hours It's just the assumption. And you can also define uh, where the working volume of this tank. Maybe you can just put in the low level till the high level. Okay, so for the working volume is just equal to, let's say, for the VL. Okay, so the Q2 is equal to VL per 2 hours, or we can say the hour is just as TH for time to holding time. Okay, so we can elaborate more in this one, so that we have for the, sorry, we have, okay, this one is VL and the TH. Okay, so for the key rated of the pump is the summarize of the Q1 and the Q2. Okay, key rated is Q1 plus Q2. Q1 is key, GV1 plus key, GV2 plus V working volume, V for the working volume of the tank number 2, and total holding time that you have specified on your project specification. Okay, so I think this is the key rated. If you have the pump curve here, sorry, I will draw at the bottom of this equation. If you have pump curve like here, and then you can also, so okay, this is the regime operation point, so you can drag to down, and the key, this is the key rated. You can also put this value to this one. So now you can specify how much the key rated that your pump should be transferred. Yeah, this is the key rated. So the next session of my video, I will explain how can we determine how much the head, how much the head of the pump should be. Yeah, if we can relate it of the head. Okay, on the next video, I want to explain how we can determine this head of the pump. Yes, as we can, so as my previous video, that the head is just difference between the pressure discharge of the pump and the pressure suction of the pump. And then we have to calculate first how much the pressure discharge of the pump. Can calculate this one, and also we have to find the value of the pressure suction of the pump also. And then finally we can calculate of the head of the pump. Okay, I think that's all for me for this section to determine how much the key rated of your pump. Yeah, please note that This curated of the pump is depend on your demand. It is depend on just on your demand of is the curated of the pump is demand of your process plan demand. Okay, so as a process engineer, you have to specify first how much the key flow in kg per hour or meter cubic per hour. That should be defined first. It is depend on what the complexity of your plants. Maybe you can use the cooling water, or you can filling out the time. Let's my previous example, or you can also have to like dilution of tank or like the superheater, also etc. It's very important to know that you have to specify the first of the curated of your pump, that it will be depend on your process plan demand. So is your process engineering job. Okay, that's all from me. Thank you for your pay attention for my video. Tomorrow we'll to talk about the head of the pump. Okay, see you on the next video. Thank you. Bye bye.